So once again, good morning to you all. The topic that we are going to discuss now is context of a process. So the context, the meaning of the word context is we used to term it with some different terminologies, aspects or basis or environment. So here we are discussing on what process. So a context of a process. So here context which deals with aspect of a process or basis of a process or environment where that particular process is running. So that's about the context of a process. Okay. So these are the various meanings that we could give to the word context. So on what basis a particular process is running or in which environment that particular process is running. Okay. And to which domain that particular process belongs to, whether the particular process belongs to a particular document or particular presentation or particular application or particular IDE. So which domain it belongs to. So all these things which refers to the context of a process. Okay. So basically here we have some three domains in context of a process. The three domains are: the first one which is about user address space. We used to call it as an user address space. And then the next one which is about the hardware registers. The second one which is about the hardware registers, and third one which is about kernel and data structures. So you have three domains under this context of a process. Okay. So under these three domains, the first one which deals with user address space. So user address space, so whatever the user program that you're going to execute, for each and every program you will have some number of process. Okay. So whatever the process that we are executing and the basis of user, so all those processes which comes under user address space. So that's the thing about user address space. So in user address space, so you may run a Word document, or you may run a PowerPoint presentation, or you may run a NetBeans IDE, or you may run a Photoshop. So whatever the application or software that you're going to run, for each and every program or each and every application, we will have some n number of processes. So these programs which is being executed by user, and then each and every program which is going to have some n number of processes with it. Okay. So by collectively we used to call these things as user address space. And then we are using the term address space over here. The purpose of using address space is, here we are going to deal with what, the memory spaces in your computer systems. So for each and every program you need some memory spaces. So those memory spaces will be occupied by that particular program in terms of process. So each and every program which is going to execute it, or which will get executed in forms of process, for those process to work, so it needs some memory spaces. So those memory spaces which is being referred here as address space. So it's very simple. So user address space, here user he is going to execute some program, the program which is going to be in terms of process, and making that particular process to execute, we need some memory spaces. Those address space here we are calling it as an user address space. So the word user here refers to whatever the user program, each and every individual user, they are going to execute some program. That's why we're calling it as an user address space. So that's about user address space. And the next one which is about hardware registers. So hardware registers, in the sense you will have learnt in DFC, digital fundamentals. So and then in principles of compilation also you people have came across this particular term, registers. So registers, in the sense, actually which is going to be an component, or which is going to be a memory area or memory space that you have in your computer memory, or that you have in your computer system. So those registers which will be used to store the names, store the data names, it used to store the data values, and then it used to process those data. So whatever the data that you're going to store and process, for all those data we need some memory portions to store and process. So for that we used to use what, registers. Normally in programming languages like assembly programming languages, we have used this terms registers. So using registers only, we used to do some computations like additions, multiplications. So those computations will be performed using registers. Similarly, here to execute some process, we need the support of registers. So the process which may have some data, to execute that particular data, we need some what we need some memory spaces. Those memory spaces which will be referred here in forms of what registers. So basically, which is going to be some memory spaces. Using those memory spaces, we are going to do some process over there. So that's about hardware registers. So for accessing and making use of that particular registers will be here in this particular context of a process. So for a particular process, we are going to access those registers and we are going to make use of that particular registers. That's about hardware registers. And then the next one is about kernel and data structures. So kernel, the kernel which is going to be the central controller or the manager of the entire operating system, and to this kernel you will have some various data structures. So with those data structures only we would be able to process the process. So here this particular topic, context of a process, which completely deals with what? A process context. So here we have some three context part. The first context which is about user address space, and second context which is about hardware registers, and third context which is about kernel and its data structures. So kernel which is going to have some various data structures. So using those data structures only we would be able to process various thing related to a process. So we would be able to do various thing related to a process. So surely we need the support of this user address space, then hardware registers, kernel and data structures. So suppose we are going to compare these three domains with Unix system structures. So you will have user space in your Unix system structures, and then next you will have memory management system and memory management subsystems in your Unix system structure. And then also you will have what? You will have that kernel management, the center of your Unix system structure, the entire thing, all those subsystem basically which comes under kernel. The kernel and its data structures will be coming under and what your second part of your Unix system structure. And finally at the third part you will have hardware. So here we are using some hardware as in registers as in hardware. So all those three things, the user, hardware and kernel of your Unix system structure will be here in this context of a process. So by comparing these three things, user address space and then hardware registers and then kernel data structures, we could compare with these three things with Unix system structures. Okay. So these are some important domains that we have. The next thing that we are going to discuss is we have three things, actually user level context, and then you have register context, and then you have system level context. So these are the three contexts that we deals with. So the first one, user address space, which deals with user level context. Okay, and then the second one, hardware registers, which deals with register context, and the third one, the kernel, which deals with system level context. So basically we are grouping these three domains with three contexts. So the first one, the user address space, which is related with the user level context. Okay, and then the second one, the hardware registers, which is been related with the register context, and third one, the kernel, which has been related with the system level context. So these are the three important contexts that we have. So make note of these things. So whenever that they're going to ask what are the three contexts that we have related to a process, you have to mention these three things. The first one which is about user level context, and second one which is about register context, and third one which is about system level context. It's very simple. So user level context in the sense was whatever the user program that you're going to execute, for each and every program you will have some process. So those process which is being referred here as user level context. Okay, so for this you have some various data structures that will be discussed along with your slides. And then the next one, register context. The register context in the sense to process your data of your process, to make your make use of the data that present in your program. We need some memory spaces, or we need some hardware to store and process. For that we are using registers, and then there you will have some various components basically. So in register context we have some various components. So those components we should discuss with the slides. And then the next one, which is about stack pointer. So this is going to be subtitle which comes under user level context. and this stack which will be referred by two things, both by user and also kernel. So which is you people know very well about stack and various process about stack. So here we used to use the stack pointers. Keep this stack in a simple way. So stack, which is going to be what, a data structure. So to this data structure we are going to put process, and then we are going to make use of process. It's very simple. So for a program you will have some sequence of process. So all those sequence of process will be get stored in this stack, and then using this stack we are going to manage the process. So what is the first process that we have to execute, what is the next process that we have to execute, and to calculate which process which has some highest priority, and then to which process that we have to execute first. So all those things will be done using this stack. A stack which is going to act like a data structure to put your process and to execute a process. You are going to use this stack. And finally we'll have about the system level context, nothing but a kernel, the kernel which is going to manage the entire system level context. So keep in mind that normally soon after starting up of your operating system, you will have these things. What you will have some n number of files that will be working in the background. So soon after starting up of your operating system, approximately there will be some few thousands or few hundreds of files which will be working in the background of your operating system. So that's going to manage your entire operating system. So basically you will have some n number of DLL files. We used to call them dynamic linking libraries. Using those DLL files only, which are going to manage the entire operating system, and using those DLL files only, we would be able to execute our user level context programs. So whatever the user programs that you're going to execute, using those system level context only, the user level context will get executed. So without the support of system level context, we won't able to execute the user level context. So the system level context will be there in your system throughout the entire lifetime of your system. Here lifetime, which refers to the starting of your operating system and shutting down your operating system. So the entire thing we used to call it as an lifetime of your operating system. Okay, so till starting up until shutting down, you will have what, the system level context. And then you have two more things, the static part and dynamic part. The static part which deals with the system level context, and the dynamic part which deals with the user level context. Here I am referring the system level context as static part because it is going to exist throughout the entire lifetime of your system. That's why we're calling it as a static part. And then dynamic part, in the sense we user dynamically we used to change the programs. First we execute some one program, and next we execute some other program, and then further we execute some other applications or softwares or anything that we need. Or we may execute we may run a browser and we may access internet. So anything that you're going to do. So the dynamic part which deals with the user programs, whatever that you're going to execute, the user level context which comes under dynamic part, and then our system level context which comes under static part. Okay, so that's how I have actually grouped uh, these things. Okay, keep in mind we have some three basic domains. What are the three basic domains that we have? The first one is user address space, and second one is hardware registers, and third one is what, kernel and its data structures. And then so these are the three domains, and then we have three contexts. What are the three contexts that we have? The first one is user level context, and second one is register context, and third one is system level context. So these are the three contexts that we have. And then you have two paths. What are the two paths you have? The static path, and then you have dynamic path. The static path which deals with what, your operating system environment, or which deals with system level context. Okay, and then the next one, you will have a dynamic path which deals with your user level context or user processes. Okay, so these are the various basic things that we have related to context of a processes. And then here it's very simple. So the user level programs or user processes or anything that we do related to user which comes under user level context. And then the kernel, and then the system, and then anything related to operating system. we used to call it as an user level, we used to call it as in system level context, or else we used to call it as in kernel level context. Okay, keep it in mind. So whatever the thing that we do, or whatever the thing that your operating system it used to do, so all those things, all those processes related to operating system, which comes under system level context, or else we used to call it as in kernel level context. Okay, so these are the various basic introduction that I would like to give related to context of a process. So now I would like to enter into the presentation. Soumya, would you please open the presentation, ma?
Yes, sir.
So basically we have some various data structures for each and every context. For user level context you will have separate data structures, and then for register context you have some various components and data structures, and then for kernel also you will have some various data structures. So these data structures are very important. And then the next classes, in the upcoming classes, we used to deal separately with the kernel data structures. So after completing the data structures, we are going to complete the unit 1. So the kernel data structure, which seems to be a very important one, we will discuss about the kernel data structures in the next class. Okay. Now, uh, which is about what the context of a process. Move to next slide, please. We could expect this particular question for about 70 percentage in your university examinations. Okay. So coming back, so already I have explained you the context of a process, which consists of what, which consists of three things. I named it as three domains actually. So based on these three domains only, the entire context of a process will get executed in your system. So the three domains are, the first one is user address space, which is going to be the first domain. Second one is hardware registers, which is the second domain, and third one is a bit which is about kernel data structures, which is going to be the third domain. So totally we have three domains related to context of a process. Okay, so make a note of these three things: user address space, hardware registers, and kernel data structures. Okay, so user address space, which deals with what, so whatever the user program that you're going to execute, it may be user 1, he may execute some program, or user 2, he may execute some other program, or user 3, he may execute some other program. But for each and every program, what we used to have, we used to have some n number of process. Okay, it's very important. So whatever the thing that you're going to execute in your system, it will get executed only in forms of process, not in forms of data, or not in forms of application, or not in forms of programs. Okay, so whatever the programs or applications or softwares or anything, process, whatever the thing that you're going to do over there, which will be get converted into process, we're going to place this process in your computer memory, and then process will get executed. So whatever the user programs that you're going to work out, for each and every programs you will have some process. So all those process we used to call it as an user level processes, or user processes. So here the address space, which refers to the computer memory that we're going to occupy in your operating system, or in your computer system. So those things we used to call it as an address space. And here user, the word user, which refers to a user level process, whatever that we are going to execute. Okay. The second one, which is about hardware registers. So now we have process, and then we are going to execute process. And then these process must be placed in some hardware locations, and by placing it in hardware locations we are going to execute. So where we are going to place it and how we are going to execute. So you will have the hardware registers in your computer system, and we are going to take this process, and then this process which may consist of some data, those data will be placed into the registers of your computer, and those registers will be working, or which is going to be helpful for that particular process to do its work actually. So that's about hardware registers. So you'll have some hardware components, those components which is going to be in forms of registers, and then that will be used to make your process to execute. And then basically a process which is going to access that particular register, and which is going to make use of that particular register. That's very important. Then the third one, which is about kernel data structures. So kernel data structures in Unix, you will have various what system level processes. So whatever the system level processes that we are executing in an operating system, all those things which comes under a kernel. And then data structures, we have some various number of data structures. So using those data structures only, we would be able to uh, make a process to run. So the process will make use of those data structures, and then it will make some entry in those data structures. So whenever a process is executing, it will make some entries regarding its process or regarding its work. It used to make some entries in those data structures. So you have some data structures, and that will be discussed in the upcoming slides. And then you have what you have um, the all these three things, the user address space, hardware registers, and kernel data structures, together the union of these three things will be referred as context of a process. So whenever you have some one mark question as what is going to be the context of a process, you could use this answer. Context of a process, which is going to be the union of user level context, that's about user address space. The second one, hardware registers, that's about register context. And third one is about kernel, that's about system level context. So whenever that they're going to ask what is mean by context of a process, you could give this answer. The answer is the context of a process, which is going to be the union of user level context, register context, and system level context. Okay. So that's the thing. And then the next one, we are going to deals with each and every context. And the first one is about user level, and the next one is about register, and finally which is about system level context. The first one, user level context, which is going to have some four things over here. So these are some of the data structures that we have related to user level context. The first one is about process text, and the next one is about data, and third one which is about user stack, and fourth one is about shared memory, or else we used to call it virtual address space. So this is important. Already we have discussed about this shared memory and virtual address space in the previous classes. So once again I will tell you about these things. So process text in the sense, so a process, whatever that we are going to execute, those instructions, whatever the instructions that we have related to process, so whatever the instruction that particular process is going to execute, so those things we used to call it as a process text. So process text in the sense, for each and every process you will have some instructions. So based on the instruction, the process will get executed. So those instructions we used to call it as in process text. And data, and which data are on what data that particular process it's going to work. Okay, for example, you're going to run up a notepad program. Here notepad, which is a program, and then whatever the actions that you're going to do, those actions which is going to be which is going to be in forms of process. Okay, and then data in the sense, whatever the content you're going to type it in forms of paragraphs over in a notepad, those content here we used to call it as in data. Okay, so the notepad, whatever the content that you're going to type in forms of sentences and paragraphs, those things we used to call it as in data. Okay, and then user stack, which means, so for a single program you will have what, you will have some n number of processes. For each and every process we need some we need some structure to store and process. So you will have stack over here. So in the stack you will have the process 1, process 2, process 3 until process n. So you will have some n number of processes in the stack. So based on the stack, you will have some priority of the particular process to get executed. So if it's going to be in the top of the stack, that particular process will get executed first, and suppose which is going to be in the second location of your stack, that will be executed next to the first process. So stack, which is going to be acts like environment, which is going to act like a data structure to put the process, and then to make use of that particular process. So it's very simple. Process text, which is nothing but what, instructions, and then data, the content of that particular program, and then stack, which is going to be the data structure for processing your process, or for working your process. That's about user stack. And then the third one, last one, is about what, shared memory, virtual address space. So here we used to deal with two things, as we used to call it as an physical addresses, and then hardware addresses or virtual addresses. Okay, you have two things here, physical addresses and then virtual addresses. um, so you have two things over here. We have some mapping in between these physical addresses and then virtual addresses. So here we are referring the physical addresses as whatever the addresses that we have in main memory, we used to call as in physical addresses, and then whatever the addresses that we have in the secondary memory, those addresses we used to call as in virtual addresses. Sometimes we won't have enough memory spaces in your primary memory. At those times, we are going to borrow some memory spaces from secondary memory, and then we're going to make use of those memory spaces, whatever that we have in the secondary memory. So you will have some link between this primary memory and secondary memory. So you will have some mapping between this primary memory and then this secondary memory. So whatever the memory spaces that we have in the secondary memory, we used to call those memory spaces as virtual address space. It's very simple. So you will have some sharing between shared memory between the primary memory area and secondary memory area. So that's why we used to call it shared memory. Sometimes for a process to execute, we won't have sufficient memory spaces there, and then part of the process will be there in primary memory and part of the process will be there in secondary memory. So we used to call this mapping process as virtual address space mapping, or mapping the physical address space with virtual address space. Okay, so that's about shared memory. So a particular memory will be shared by a process. So we used to call it shared memory. Move to next slide, ma. Move to next slide, please. Okay, next which is about register context. So here in register context you have various components like program counter. So program counter in the sense it used to count the programs actually. It used to count the process actually. So process 1 plus 1, process 2 plus 2, and process 3 plus 3, and process 4 plus 4. So like that it's going to count the process. Okay, so how many number of processes that we are going to execute for a particular program. So we used to call it as a program counter. So register context, which is basically what the memory spaces. Okay, so how many number of program that we're going to execute and how many number of registers that we need. So you'll have some mapping, you'll have some link between the program counter and registers. And the next one is about processor. So how many number of programs that you're going to execute. For each and every program we need some processor. We used to call it as a processor status register. Suppose you are going to have a quad core processor, and the program 1 will get executed in core 1, and program 2 will get executed in core 2, and program 3 will execute it in core 3, and program 4 will get executed in core 4. But for each and every program you will have what? You will have some n number of processes. So the processor whatever that we have, how it is going to get connected with register and how it is going to execute. So to make use of the processor and then its status, whether it is working or not, so what is the program it is running, so those status will be noted down here in this processor status register. So these are the two components that we have under register context. The first one which is about program counter, and the next one which is about what? Processor. Actually we used to call it processor status register. Okay. Which is going to be maintained what? Which is going to maintain the hardware status. So the register itself which is going to be in hardware, and processor which is going to be in hardware. So how these hardware is working according to the process that you are executing. Okay, and then you have various things like what is the recent computation that you have done using that particular register. And then suppose if it's going to be an indefinite execution, or whenever that you're going to execute a program, suppose if it's going to be indefinite loop, automatically it stands in register overflow over there. So that's about register overflow. And then the processor execution level, suppose if an interrupt is going to come, how your processor is going to work, or how your processor is going to manage it. So processor execution level. And then current mode of execution, normally we have two modes of execution. The one is user mode and kernel mode. So in process states and transition we have learnt about this modes, two modes that we have, user mode and kernel mode. So whenever a process it have to complete its work, first it have to move to user and then it have to come to kernel, and by being in kernel it used to complete its work. So that's about, so what is the current mode of execution, whether it's running in user mode or kernel mode. So all these things which comes under register context. So what is the hardware that we are using, what is the program counter that we are using, and processor execution level. So all these things which comes under register context. Move to next slide, please. Move to next slide now. The next one is about stack pointer. So stack pointer which deals with what we will have stack, and within those stack we are going to put the process as process 1, process 2, process 3. So entire stack structure you will have some number of processes with it. So Depends upon the stack pointer, we are going to execute that particular process. Suppose if the stack pointer points to the zeroth location, it will execute the process which present in zero location. Suppose the stack pointer points to the first location, the process which will be present in the first location will get executed. So the current address of the next entry in the kernel, the current address whatever we are going to execute. So each and every process will have some address. So what is the current address that we are going to execute? And then what is the next free entry that we have, whether the stack which consists of some any free entry to occupy the next incoming processes. So to make a note of whether does it have any free entry with it, we used to check it out. And then you have some general purpose register to manage these things, the stack environment. You will have some general purpose register. So the general purpose register will be helpful to manage the stack environment. And then whenever you're going to create a new process, or whenever you're going to perform some new action, and then that particular process will create some new data for it. So the data will be generated by a process during some file execution. So any updations of the file, or any changes in the file, or any new action that you're going to do on a particular program, so a new data will be generated by a process. So whenever a file is get executed, uh, that particular process will generate some new data with it. So and then next one, the transmission of data for communication purposes. You will have some transmission of data between a process and kernel. So kernel, it used to ask some question to the process whether it have completed its work. So kernel, it used to check the execution process of, or the working nature of a process. So you'll have some communications. So those communications will be performed in the stack environment. So the stack environment, which consists of what is the process that we have to execute next, and does it have any free entry or not, and then what is the register that we're going to use. We're going to use some general purpose register for it. And then a process in the stack which is going to create some new data whenever needed. And then you will have some transmission process between the process and kernel. So all these things which will be happening in what your stack environment. And then we are calling it as a stack pointer over here. Okay, move to next slide, ma. Move to next slide, please. Okay, so here we have what system level processes. So here we deal with the kernel data structures. So as I told, the static part which deals with what are the process that we have related to your kernel or operating system, and then which presents throughout the lifetime, the process which presents throughout your lifetime of the system, we used to call it as a static path. And dynamic path in the sense, whatever the user level processes that we have in the stack, we used to call it as a dynamic path. So you will have some context switching over here. So whenever an interrupt which is going to come in between, we are going to give preference to the interrupt, and then the control go back to the next process whatever that you have in sequence. So we used to call it as a dynamic path. So keep it in mind, static path which refers to the operating system process, and dynamic path which refers to user level process. Okay. And then here kernel which used to perform some action like pushing and popping. So pushing the process into the stack and popping the process from the stack. So whenever a new process it have to execute, it will be pushed into the stack. Whenever a process which is going to complete its work, it will be popped down from the stack. So that will be performed by your kernel. And then you have some various data structures. So all these data structure which comes under system level processes. So that's why we are discussing about this kernel data structures under system level processes. So you have data structures like process table entry, and then U area, and then P region entries, and then register tables, and then page tables. So all these totally we have about 3 4 5 data structures. All these data structures which is going to be, we used to call it as kernel data structures. And then you have one more thing, kernel stack, but we won't give much importance to the kernel stack. But this process table entry, U area, P region table, and then register table, and then page table. So all these things we used to call it as kernel data structures, where the process table entry which deals with the state of a process. So what is the current state? So you will have some 9 states in process states and transition. So what is the current state of a process that will be there? Those information will be there in the process table entry. And the next one, which is about U area. So you just have some process control information and process priority. So those information, process control information and process priority will be there in U area. and then p region entries, register tables, and page table. So all these three things, which is going to have some mapping between your virtual addresses to physical addresses, as we discussed just now. You have some mapping between the primary memory and secondary memory. So for mapping purposes, between this memory location, we are using this p region entries, p region which denotes process region, and then you have register tables, and then you have page tables. So all these things that you have over here, and finally you have kernel stack. Kernel stack nothing but you will have user stack or kernel which is going to push and pop the process over there. So move to next slide, please. Move to next slide now. So the dynamic path, so stack, last in first out. So whatever the thing which is going to come last, that will be uh, pushed out first. So that's about last in first out. Um, but basically, though we have mentioned it as last in first out, it used to work in what FCFS basis only, first come first serve basis only. It used to work. So kernel which used to pushes um, pushes context layer here. Here this slide which deals with the interrupt. So whenever an interrupt is going to come, always we are going to give priority to interrupt, and then the control go back to the normal processes whatever that we have in sequence. So you will have some context switching. So switching from the normal process context to interrupt process context. So these types of switching the context from a normal process to interrupt process. So that will be managed by your kernel. So you will have some pushing and popping mechanisms in the stack. So that will be performed by your kernel. Okay. So basically, these interrupts are done for the purpose of completing the system call execution. So operating system, it may perform something additionally. Those system calls will get executed in forms of interrupts. So computer system calls are your operating system calls. Whatever that we have, we used to call it as an interrupts over here. Okay. So for handling interrupts, we used to use these things. Um, um, so move to next slide, ma. Move to next slide. Soumya, move to next slide, ma. Okay. And so these are things already we have discussed, the static path and then dynamic path, dynamic portion and static portion. So the dynamic portion which deals with the user level context, where the static portion which deals with system level context. So don't be in confusion. So the dynamic portion which deals with user level context, and static portion which deals with system level context, and then they have once again they have referred those data structures over here. And then you have some various layers like kernel layer 0 or kernel layer 1 or kernel layer 2, stack layers actually. Okay, so you will have some separate stacks. For user level context you will have a separate stack, and for system level context you will have separate stack. In those stack you will have some various layers as layer 0, 1, 2, 3. Depends upon the process, either process 0 or process 1 or process 2, you will have some various layers. So those layers which has been mentioned over here in this slide. Move to next slide, ma. So I think so with this we are completing this particular topic. So move to next slide, ma. Soumya. So with this we are completing this particular topic, context of a process. So okay. So the next topic which is going to be IPC. So we will be discussing about this IPC in the next session. IPC stands for inter-process communication. So with this I would like to complete the session. So thank you students, thank you for listening patiently. So thank you students, thank you.